Sorry about that again, guys. I got cut off, so there's going to be another few minutes here at the end. Okay, so what I was saying is that I can choose any temperature scale, but my absolute zero has to match. And so it has to be 0 here at the end, all right? And so I could call this 0 degrees P for like the Peter scale, okay? So I can make my own scale. Now the last thing I want to talk about, and I'm going to put this again in red because it's part of the lecture, but it's not supposed to be part of my chart, is what do we do when we see a temperature come up in an equation, all right? Well, the first scenario we might see is that the equation is something like A equals B delta T. So you guys have probably seen the delta symbol before. It means the change in something. So if we're talking about two temperatures, it's just a temperature change. And that's marked by having a distinct final and initial point. And the delta of any variable, so delta T in this case, delta is final minus initial. All right, so it's just changing. On this chart, that would correspond to a chopped off section. So no matter where I am, I'm just looking at a section. Maybe it changes from freezing to boiling. So here is my delta T, okay? And that's what I want you to think of when you see delta T. Think of me doing this, all right? Giving you a defined section on a temperature scale. And so with delta T in your equations, you can use any scale you want to, all right? You have to make sure that the units match, like if the whole equation's in metric, use a metric scale. But like what I mean is Kelvin versus Celsius. You can use either one, because if I have 2 degrees, here I've got 2 degrees, these 2 degrees are going to be the same 2 degrees difference in both Celsius and Kelvin scales. It doesn't matter if I do, let's see, 2 minus 0 is the same thing as 275 minus 273. Okay, these guys are both equivalent. You see that? It gives the same answer, 2 degrees. Doesn't matter what scale I'm in. Now, the thing I want to contrast that with is a scenario where we have something like this. Sorry. Now here, it's just the variable of temperature itself. I'm not talking about a change in temperature. I'm really talking about how far from the 0 point am I? From absolute 0, how far up the scale I am. So when you see a T by yourself, think of me doing this, up the scale. Okay, how far have I come from absolute 0? And for that reason, we have to use a scale that starts at 0. So this one, always use absolute 0 scale. It's a must. The reason why is that if I'm looking at how far I've come from 0, and I decide to use, say, Celsius, let's say, oh, I'm going to throw a number in Celsius into that equation. Celsius thinks that 0 is here. Remember, Celsius says, oh, 0 is here. So this temperature, let's say I'm right here. Okay, you are here on the scale. Big difference whether it thinks that you've come this far from 0 or whether you've come that far from 0. So if you don't use a temperature unit in an absolute scale, usually going to be Kelvin because that's in civilized units, then you're going to get the wrong answer. Okay? So that's the last distinction I want to make. So that's kind of an overview of temperature, and then the next time, the next lecture is going to be the equivalent of this, but for pressure. Thank you guys.